Hi everybody, welcome back to my channel. And today I have another video of a classic Rockford Fosgate amplifier. This time I have the Punch 40i DSM on the bench. This amp is also user supported and it was in great condition. Even the warranty seals were completely intact, but this forces me to take a look under the cover. And here are the ratings. The amplifier is rated 20 watts per channel at a battery voltage of 11.9 volts. Here you can make your connections to the battery, ground, power and remote. And on the other side you have the speaker terminals, you have the two gain ports for each channel and also two parts for the bass and the treble. And the bass gives you a boost of 18 dB at 45 Hz and the treble knob gives you a boost of 12 dB at 20 kHz.
And now I'm starting with an 8 ohm monoload to check both channels with continuous power into a 4 ohm load, both channels driven into full power. I start with a continuous power test with 1 kHz driven into a 4 ohm load per channel, both channels driven by connecting an 8 ohm monoload to the amplifier's bridge terminals. 1 kHz is the first test. Clipping. I got a peak voltage of 41.6 volts. The amplifier delivers 55.5 watts of continuous power with 1 kHz into a 4 ohm load, both channels driven into full power. Now let's have a look at the amplifier's efficiency by measuring the input current. There's the idle current around 0.4 to 0.5 amps, and now I give full power into both channels with a 1 kHz input signal. We have 11.4 amps. The efficiency of the Punch 40i DSM is around 71.1%. And another continuous power test, but this time with 50 Hz. Oops. I got a peak voltage of 40.8 volts. With 50 Hz the amplifier delivers 53.3 watts into a 4 ohm load, both channels driven. Testing for dynamic power, I take one, so I have the first cycle and the last cycle at the same voltage level. I observe the last cycle if there's clipping. There's a little bit clipping. I'm going to reduce it to avoid the clipped signal. Now it's okay. And going back to the signal, I have around 41.2 volts, so there's no dynamic headroom with 20 cycles. And there's also no dynamic headroom with 8 cycles. I also tested. Maybe in lower impedances. And now there's only one big power resistor with 4 ohms connected to the bridge terminals of the amplifier. That means I test both channels driven into full power with 2 ohms per channel. Let's go. 1 kHz continuous power test. In this case I got a peak voltage of around 36.8 volts. The Punch 40i DSM delivers 86.8 watts into a 2 ohm load per channel, both channels driven with 1 kHz. I'm testing for efficiency. How many amps is the amplifier pulling out of the power supply? Idle current around 0.4, 0.5 amps. Now I give continuous power signal into 2 ohms, both channels driven, full power. 19.9 amps. All channels loaded with a 2 ohm load means the amplifier has an efficiency of 63.8%. The next continuous power test, but this time with 50 Hz. The peak voltage is around 35.6 volts. With 50 Hz the amplifier delivers 81.2 watts into a 2 ohm load, both channels driven into full power. Now testing for dynamic power with 1 kHz and 20 cycles. All cycles at the same voltage level, that's good. I check out the first cycle and the second cycle. Okay. I go to the last cycle. No clipping here. So I'm going to check out the peak voltage. That's 37.2 volts. Dynamically with 1 kHz and 20 cycles, the amplifier delivers 88.7 watts. Dynamic power input signal of 8 milliseconds. I also got 37.2 volts. Just for fun, I tested with just one cycle. I have to say the signal doesn't look very clean with just one cycle. But we got, let's say we calculate with 40 volts, then the amplifier delivers 102.5 watts into a 2 ohm load of dynamic power for just 1 millisecond. And now two 1 ohm resistors are connected in series to the bridge terminals of the amplifier. That means I am testing 2 ohms mono. That means 1 ohm per channel, both channels driven into full power. But I'm just going to test for dynamic power. I don't want to heat up the amplifier. Dynamic power with 20 cycles. We have all cycles at the same voltage level. They look okay. I go to the last cycle to check if it's also okay. They are also okay. So I go and take the voltage. And then we have a voltage of 30.8 volts. Now testing with 8 cycles. Here we have the first cycles. It says around 30.8 volts. All at the same voltage level. First pause, next cycle. Switch to the one of the last cycles. And they also look okay. We have also 30.8 volts. And as always, just for fun, 1 kHz cycle for just 1 millisecond. We will get some dynamic headroom. Maybe. Okay, signal doesn't look too good, but we get a higher voltage. And the voltage is around 34.4 volts. Just for demonstration, I'm going to show you how the amplifier's output signal looks like if I do a continuous power test, 1 ohm per channel, both channels driven, and I'm not getting full power, I'm not getting the power I have into a 2 ohm load. So this is why I just test for dynamic power. And let's have a look. Here's the signal, looks clean. And check this out. I increase the gain a little bit slower and look what happens. I increase more. That's it for now. So dynamically the amplifier puts out a lot, but continuous power wise just a few watts. This is the reason why I don't use a continuous power test into lower impedances like 2 ohms mono. For music signals it's not a problem what you saw here in this test, because the crest factor of this continuous power signal is very low, it's 3 dB. If you listen to music you have typically 6 to 15 dB of crest factor. That's the difference between the peak voltage and the RMS voltage. So this is something like simulating music power. That's the reason why I use dynamic power tests.
Now it's time to have a look how this amplifier sounds on some inexpensive bookshelf speakers. if you want to support my channel, then please subscribe and hit the bell button to get info for further videos I'm publishing in the future. Thank you very much in advance. See you next time on the next ampdyno video, and thanks for watching. Bye bye.